Hey, what's up, people? I have this AMP'd wireless smart plug that I've had for many years now, and over the years, I've actually used it for like a lot of different things. More recently, it's actually spent its time plugged into a fan that we have in our bedroom, and we use it to like turn it on at night before we go to bed. Sometimes just to kind of like pull air through one of the windows and have it blow out the other side. And that's because our bedroom is the last one to get sunlight during the day. And so, like, especially during summer, it turns into like an oven up there. Like, even though the walls and like ceiling and everything are insulated, I think the walls just like hold so much heat that it kind of like slowly like radiates in. And so things can be miserable. So if we can at least like turn this on before we go to bed, we can at least like pull some of the fresh like night air through the window and like cool down the room at least a little bit just to make it more tolerable. And I mean, it's been working fine. There's nothing remarkable about this outlet at all. It's just plugs in. We have the fan plugged in on the other end. And then that way we can like turn it on and off. But in order to like control it, you have to use their app. That's it's called like Smart Life. And so you make your account and everything. You log in. And I've actually just been using like Google Home to control it, so I can like turn it on and off with that. But recently, I've been messing a lot with Home Assistant, and I would like to get this outlet to work with Home Assistant. Unfortunately, I could not find like any integration or like anything in hacks to be able to use this particular brand of outlet with Home Assistant. And so, you'd think I'd do the reasonable thing and maybe just go and find me an outlet that, was compatible with Home Assistant, right? I would just go and find an outlet that was compatible with Home Assistant, right? Nope. I went out and bought two more of these. So why did I do that? Well, since I've been messing a lot with Home Assistant, by extension, I've also been messing a lot with ESP Home and some of these ESP8266 modules. And I had a feeling that I could probably modify this one and install ESP Home on its little Wi-Fi module that's inside, because I had opened this up before, so I kind of knew what was in there. And lo and behold, it totally is possible. And I actually already have one of these modified. I have it right here. So this is the one that we've been using. So this one is not modified yet, but this one is. However, the module that's inside of these does not say like ESP8266 anywhere on it. But after doing some searching, I searched for this TYWE3S. It turns out that this is just another ESP8266 module. And so there's really like nothing special about it that I found. It's easy to just flash ESP Home to that and then, configure it so that it'll actually run the relay and operate the LEDs. And that's about it. So now I can totally ditch the proprietary app for this brand and go with ESP Home instead. Why did I buy two more though? Couldn't I just have bought like an extra one and kept the original in operation while I tried to get this one working? Well, yes, but for one, they're not that expensive. And two, I wanted to have one that I could dismantle like as much as possible in order to reverse engineer it and figure out where all the GPIO pins went to what on the board. And so I've determined that on the two LEDs that are on the board, each LED goes to an individual GPIO pin, and then the relay is controlled through a transistor with another one of the GPIO pins. And so removing the board from the rest of the casing actually made all of that like extremely easy to figure out. And so I have a little post-it here where I wrote down what everything went to, so we can see how I have like each GPIO pin from the ESP8266 module going to what. So like GPIO 14 goes to the relay transistor, it goes to the base, and then 13 goes to the blue LED positive, the 5 goes to the button, and the button is sitting there next to where the module would go soldered. And then GPIO 4 goes to the red LED positive. And then GPIO 15, I have no idea why this goes to ground through a 1K resistor, but it does. That's just how it's configured on the board. And as far as the LEDs go, this one is the blue LED, and then the one up here is the red LEDs. So those can be used to like indicate, different states of the plug. And on the original plug, like non-modified, the blue one is used to indicate when it's got a connection, and then the red one lights up when the relay is on. So I wanted to kind of try to like simulate something similar. I know that I'm not going to be able to get it, completely 100% to be identical. Now, one thing I didn't like when I opened this up that I realized is that this grounding terminal is not very well connected to the actual pin that sticks out the back. And so as you can see, I can just kind of like easily pull that off of there. and that's not exactly reassuring. And so it's supposed to be where the end of that pin is supposed to be kind of like crimped outward so that it kind of holds this terminal captive. But it doesn't appear to be crimped very well. So what I think I'm going to do is I'm just going to try to solder the end of that to this plate, and hopefully that'll be a much more secure connection, because yeah, that's pretty bad otherwise. This other one doesn't seem to be as bad, like it's not popping out or anything, but yeah, for some reason this one just was not all that well crimped on there. If we take a look at the bottom side of the module that's included inside of the outlet and one of these other ESP8266 modules, we can see that all the pins are exactly identical. So we got a transmit, a receive, GPIO 5.4, etc., like ground, VCC, and all that. So with the exception of the 6 pins that are along the bottom edge of this module, that's the only difference, is that this one does not have those, but everything else is identical. And before we get too deep into things, let me just tell you what this video is and what it isn't. It is not a tutorial on ESP Home, because I'm just getting started with it myself, so I barely understand some of it. I know enough to get the firmware loaded onto the module, but as far as how the YAML file is configured and how it, all the structure and all that needs to be, I barely understand that myself, so I'm not the person to come to for instructions on how to configure things. I had to do a lot of searching and piece stuff together until I finally was able to get something working. And so what this video is I'm hoping that maybe some of this information will help somebody that maybe has this exact same plug, that maybe, trying to achieve something similar. And so that's why I'm kind of showing my process that I use to be able to get this one working the way that I wanted to. And with all that said, we really only need access to 6 points on the board in order to be able to get this flashed. We need 3.3 volts, we need a ground point, we need the reset line, the receive and transmit, and GPIO 0. Now, ground and 3.3 volt are super easy to get to because they left these empty pads on the board. One's marked to P10, the other one's marked to P8. And both of these have ground at the topmost pad, and down on the bottom of P10 we have 3.3, and then we have reset on the bottom of this P8 pad. Receive and transmit, we can just solder directly onto the side of the board, and one of those actually has an extended pad right there with a sort of a little bit of a circular pad, so it's easy to solder that one. This one has a little less room, but it's still possible. And then GPIO 0, they left a little round pad right there on the side. And on the bottom, we see right there that this one's labeled TX, this one's RX. This one's not labeled, but this is GPIO 0. And unless you completely pull the board off the case, everything's accessible from the top, so it's not it's necessary to have to completely remove it. And I did have a GPIO 0 connected to this orange wire, but it broke off just as I started recording this part. So this would have been soldered right there. And then I had to go into this, it's basically a 10 position header, but I only have 5 wires going to it. So we're going to have to, this one's already done. This is the one that we're going to be messing with. And if we really wanted to, we could just, pull this off and keep the original firmware on it, so that if we wanted to reuse it with the original app, we can, in the future. But I don't know that I really care to do that. But it's totally possible to just take this off and replace it with an off-the-shelf ESP8266 board like this one, and solder this on, and it'll work exactly the same. And maybe just to show that it will, I can put this one on and, configure it identical to this one, and they both should work exactly the same. The only other thing we really need is some sort of USB to serial adapter, and I have these little modules that are called the VisitPort 2. It's manufactured by some company called Earth People Technology. I bought these on eBay. You can buy a 3-pack for, I think it was $12 or $15 or so. And so they provide power, they provide ground, VCC, TX, RX, and then RTS, DTR, and CTS, which we don't need for this. They have an output selectable between 5 volts and 3.3 volts. So I've got this configured for 3.3 volts, since that's what the ESP8266 modules need. And then this has something to do with some of these other pins. I don't need to worry about that. So this is, you don't need this exact same one. This is just what I happen to have on hand. There are actually some adapters you can buy that, you can pop like these little boards into and program them, and they'll have like a CH340 USB to serial like chip. And I mean, there's a ton of other stuff that you can use. I think you could even maybe like even use like an Arduino board and then just wire stuff directly to that. So lots of different options. This is just what I happen to have on hand. And so I had to kind of interface all these pins to this other header that I soldered onto the board. And so I didn't make anything custom. So I just had to use like a bunch of different adapters here just to get everything like interfaced. But there's nothing special about this. It's just tying the ground, the VCC, the TX to the RX on the board, and the RX to the TX on the board. And so that's it. It's basically just straight from here to there. Nothing else in between. It's been 2 days since the clip before this one, but in that time, I've simplified the wiring going from the board to the USB to serial module. So I just put everything into a 6-pin housing. That way I can just connect it directly to this board. And then I also reattached the original Wi-Fi module, and I've got GPIO 0 connected directly to ground instead of having like another separate wire. And I was going to use one of the new ESP8266 boards that I had sitting around, and I had actually already soldered it on there, but then I decided, nah, let's just do it with the original board. That way, you know, everything is done like as it would be, like the way that this thing comes built. And because sometimes I have commitment issues, I decided to try to see if I could figure out a way to dump the original firmware from this module and to keep like a copy of it in case for some reason I ever want to revert this back to like stock, which I can't really think of a reason why I would want to. But I got curious, and so after I dumped the ROM, I opened it up with Notepad++ with a hex editor plugin, and I just kind of took a look through the, you know, like all the data that was in there. And I came across the word Tuya. That's a Tuya. And I have seen that mentioned before in like just my kind of like searchings on like, you know, Home Assistant stuff. I never really knew what exactly it was used for. And there's a reason why I don't call myself like that electronics pro or anything like that. It's because, one, I'm not an engineer. And two, I often end up like learning something in the process of working on some of these videos. And so, contrary to what I mentioned earlier in the video about not being able to have like any way of connecting this with Home Assistant, like, you know, with the stock firmware and all that, it turns out you can, and it can be done with Tuya. So I got curious about it, and I went into the devices and services section of Home Assistant, and I clicked to add integration, typed in Tuya, and sure enough, right there it says like Smart Life, and you just enter in your user ID, which I had to get from my like logging into the app. And after I plug that in, the other one, like the original plug that we've been using, like it works. I mean, totally fine the way we'd expect it to, and pretty much like the same way I had been using it with like Google Home. But that means that it still requires you having a account with Smart Life, and you know, having it connected through that in order to be able to use it with Home Assistance. Whereas with the ESP Home, you know, this will connect directly to it, and like everything is local controlled. And not only is it local controlled, it's also controlled by this local. So anyway, yeah, we can flash this with ESP Home now. And so I need to get a little USB cable here, a micro USB that can plug into this port. And we see these LEDs flash. Nothing exciting going on as of yet. We can just see that the blue LED is just kind of dimly lit. Okay, I've got a Chrome browser window open, and I have my instance of Home Assistant loaded, and I'm under the ESP Home tab. And for some reason, this plug is not plugged in, but for some reason it keeps saying that it's still online, and it doesn't matter if I refresh this, it's stuck saying that it's online, so no clue why that is. But normally I'd be using Firefox, except that Firefox doesn't support some sort of a serial communications thing, but Chrome does, so I have to use Chrome for this. But I'm going to go down here where it says new device, and as you can see, it's cut off because of the the display resolution doesn't match the capture window, so it's cut off, and this is as best as I can do, and I don't feel like resizing anything, so we're just going to have to deal with it. So we're going to click on new device, and right here it gives you some information that it needs to be connected to a computer using a USB cable, and this is because we're going to be downloading the new firmware to the module, and that needs to be done with a wired connection. And so we're just going to continue on that. And we're going to name our configuration. We're just going to name it AWP48, and I'll just name it demo. Demo. There we go. So click next on that, and this is going to be an ESP8266. So, and then it gives us here an encryption key. If we decide to use it, it doesn't really matter too much to me right now. For now, I'm just going to skip this. So I'm going to hit skip, and here we go. There's our new device, and I'm going to edit the YAML configuration for it. So as you can see right now, we have nothing in here. I am going to actually disable the encryption. I'm just going to, and the OTA password. Everything else can stay. And I am going to copy the configuration from my other plug. So I'm just going to hit save here so I don't lose it. And this is the other plug that I have already modified. I'm just going to go to edit here. And I'll try my best to explain what this all means as best as I know it, because like I said, I'm not a pro at any of this stuff. I've just recently gotten into it. But we have several different sections here. We have an output, and this is going to be the red LED section. The status LED, that's going to be the blue LED section. The binary sensor, that's for the, I probably should have labeled it here, button. So that's the actual button. And then the switch, this is actually the relay control section. We go back up here to red LED. So we are telling it that it's a GPIO that's going to be controlling the that particular device that's connected to it. And this basically is just going to be like either like a high or a low. And so we're telling it that it's connected to GPIO4. And then this inverted right here, false. I don't think I need it for this particular case. I left it in there just in case I needed to switch it to true. I wasn't sure exactly how it was going to operate. But false does it, and that's how it works the way that I want it to. And then the ID I gave it was red LED. So whenever we call it for, whatever reason, we can just say like red LED, and the configuration knows what we're talking about. For the status LED, which is the blue one, I thought that I needed to configure this pretty much the same as it is right here for the red LED, where I have a pin GPIO4. I thought I had to put pin and then GPIO5 because that's what it's connected to. Sorry, I skipped ahead a little bit there. But anyways, for the pin here, I thought I was going to have to put a GPIO 13 right here, like right after pin. So it would have been like GPIO 13. And that does work, except that I could not have inverted underneath it the way that I have it here, where it's like right underneath pin. So I had inverted true underneath, directly underneath pin the way that it's up here. That does not work, and it will not compile. So I had to jump down, indent it twice from pin, and then it says number, and then this GPIO 13, and then we can put inverted true, and then that does work. And the reason I needed to put this inverted true here is because I wanted the status LED to remain blue when the plug is connected. And if we had a inverted false here, then when the plug is connected and it's not like trying to connect or anything like that, then the LED would just be completely off, which is an option. Like we can have it so it just doesn't light up when it's connected, but if it's flashing, that means that there's no connection. The only thing about status LED that I've found though is that it basically is a status of the, not just the connection, but of Home Assistant itself. So if there's like a pending notification, it appears that this blue LED will flash, which isn't a big deal, and I guess it's kind of a plus. Like if I ever see this flashing, then I know that there's some notification in Home Assistant, and I can take a look at it or whatever. But otherwise, as long as there's nothing going on, then this LED will just remain like solid blue, and that's kind of what I wanted. So it does mostly work the way I want it to. And then for a binary sensor, that's the actual button, the little hardware button on the board. That's also a GPIO pin, and that's connected to GPIO 5, and it's inverted true due to the fact that when we push the button, it actually pulls that line to ground. So we want the device to know that the button's active when it's pulled to ground. And so then right here, we've defined the mode that it's an input, and we also have a pull-up enabled, because otherwise, if it doesn't have a pull-up enabled, it would just kind of be floating, and the device itself doesn't know, like, okay, is it on or is it off? So we need some way to tell it, okay, like pull it high, unless the button is pushed, and then that would pull it low, and then that's how we know that it's the button's been activated. And on press, we want the switch to, we want to toggle the relay, which is defined over here underneath switch. This is going to toggle this particular section here. And then relay is like defined down here where it's ID is relay. So we're telling it that we want to toggle that part. And then this filters part, I found it works. And what this is mainly doing here is that when I push the button, I want there to be a slight delay. And I put 100 milliseconds on here so that if I like just briefly push the button, if it's not pushed in for at least 100 milliseconds, it will not activate the relay to turn on or turn off. Like if, say, like you were to brush up against the button or something and push it, if it's just for like a tiny fraction of a second, then, it doesn't change it. And so I put delayed on 100 milliseconds and I put delayed off 100 milliseconds, but the delayed off part doesn't seem to do anything because I kind of changed the values on it. And so it seems that only delayed on actually makes a difference. So I think it just has to do with the fact that when you push it, you're telling it that it's activated. So when you push the button on, set like a 100 millisecond delay before it'll actually take any action. So I think I can actually just get rid of this delayed off part, but I'm just going to comment it out for now. I think this would be more relevant if this was some sort of a toggle switch where it can be like either like completely on or off, depending on like what it's doing. Then this might take an effect. But for the purposes of this button, the delayed on is the only one that seems to affect anything. And then down here is where I have defined the relay. It's also a GPIO, so it's just going to be either on or off. It's connected to GPIO 14, and that actually goes to the base of the transistor. We don't want this to be inverted. We want, because when it's a high output, then it's going to turn the relay on, and then when the output's low, then the relay turns off. I named this relay. That's what it's going to show up as in the in Home Assistant. And then the internal ID here for like when you call it, it's just relay. So when the relay turns on, we want it to also turn the output on, which is a red LED. So you can see right here, I called it. And then when the relay turns off, we want it to turn off output, red LED. So this takes care of doing both. At one point, I had it actually set like both of them separate. So when you push the button, it would, turn on the relay or turn off the relay. And it would also do the same with the red LED. But this is more foolproof because the problem with having them separate is that you could actually go into Home Assistant and turn the LED off by itself. And then when you toggled it, that when the relay was on, the LED could be off. And then when the relay was off, the LED would be on. And so to avoid that confusion or having to like go manually fix it again, this automatically does both at the same time. And so I don't have to worry about the LED being on when the relay is off and, vice versa. So this all works pretty much the way that I want it to. And so what I'm going to do actually is I'm just going to copy this entire section. And I'm going to go to my demo one and hit edit. The only other thing we want in here that I haven't done yet is we want the web server to be enabled. And that way we can actually monitor what it's doing. And I'm going to paste the rest of that code into the YAML. And so there we are. We've got everything identical to what the other one is doing. So this is going to function exactly the same. It's just going to be on this other board. And we're going to install it, but I'm going to actually do it with the manual download option. So this is going to take a little bit of time to compile. Okay, so it's downloaded, and for some reason it's showing up as a Kodi file. I thought I deleted Kodi from this PC, but I guess I didn't. So anyways, it's a .bin file. All right, so I'm going to go back to install, and then I'm going to say plugged into this computer. And so I'm going to open up ESP Home Web, but I actually already have it up here. So this is just going to open up another instance of it. So I will just go ahead and close that one. I'm going to click connect. And because I already have it wired, I'm going to select USB serial COM7. And this should connect to the board. And that should be connected now. And so I'm going to hit install. And I'm going to choose a file that I just downloaded. It's under the downloads folder. So I'm just going to select it. And then I'm going to hit install, but I'm going to switch back to viewing the serial transceiver module because that way we can see the LEDs blinking. So switching back to that, and then I'm clicking install. And actually right here it's going to say that, it's erasing and then it's installing. So switching back to that, we can see that the LEDs there are flashing. And this is just going to go until it reaches 100%. Okay, there we go. Congratulations, installed. So now This should be operational. I have to remove this GPIO 0 from being grounded and then just reset it. But instead of desoldering the wire there, I'm just going to snip it, and then I'm going to reset the... you know what? Alternatively, I can just unplug it and plug it back in. That way it just power cycles it. And there we go. So it's blinking. And it's trying to establish a connection. Once it fully connects, it should stop blinking. Actually, it's not going to stop blinking because now in Home Assistant, we have a notification, and it's basically going to be telling us that a new device was discovered. So actually, if I dismiss that, it should get it to stop blinking. So let's, I'm going to switch back over to this, and I'm going to hit dismiss. And not yet. Still blinking. And this is not going to be able to switch this relay just yet because there is no 5 volts going to it. It's only the 3.3 being provided by the USB transceiver module. But if I click the button, this should toggle the red LEDs. So let's see if that works. Hitting the button. There it is. So that would mean that the relay is on, and that would mean that the relay is off. Well, if we go back to the ESP home page, we can see here, we can click visit, and this should pop up the relay right there. So we can turn it on and off from right there, and the LED is actually switching on the board. So it's fully connected and it's working. I just don't understand why it's still blinking. Should have stopped blinking by now. And if I wanted to make like any changes to its functionality, I can just go back into the YAML file, change around whatever I want, and then I can click install. And this time I can do it wirelessly because now we've got the firmware configured on it, and it can just update it over the air without having to wire anything to it again. So well, I'm just going to hit cancel for now. But anyways, let's show that it's actually working. I'm going to desolder all the wires from the board and pop this back into the case. And as you can see, I've already soldered the ground to that pin there, so it's a much more stable connection, and it should be a really good ground. And so I'm just going to drop that in there. I got to resolder those 2 pins in place. But before I do that, actually, I can actually show that it does work. So we're going to do this like in real time. So I'm just going to unplug it from the transceiver. And I just have to be careful here because now I am going to have mains present at this portion of the board. So I'm going to carefully plug this in. And these pins should be making pretty good contact with the board. They're pretty tight fit. So even though they're not soldered, it should still work. You can see I don't have this plugged into anything. So I'm going to push this onto that plug just like that. So that LED is going to blink until it, well, like I said, it keeps blinking. I don't know if it's going to actually stop blinking. And it did show up in Home Assistant. So I should be able to click this button now and it should toggle the relay. And it sure is. If I bring the microphone down to the relay, we should hear it click. Yeah, that's working totally as expected. I can remove the rest of these wires, solder the board onto the pins, and this is pretty much set to go. And there we go. I got the pins soldered back onto the board, and this is dangerous. Don't operate these open like this. It still does not stop flashing, and I think I realized maybe why it's continuing to flash. This was the one that I modified first. As you can see, the LED is not blinking. And I think this one continues blinking because I did not add it to like the Home Assistant homepage. I'm guessing that's why it's doing it. I'm not entirely sure. This one is on the homepage, so it's not blinking. And like I said, I think that's what the deal there is. But as we can see, if I go back to here, like click on and off right there, we can see that it changes the state of the light. And if I go to the one for this one also operates. So both of these are working with ESP Home and Home Assistant. And this is my original one that I actually still have not modified. And so I'm probably just going to use these as is for now and see if there's any benefit between like one or the other, or if there's like something that I'm still missing between the stock configuration and the ESP home. But I mean, I think everything's working the way I want it to, so I don't anticipate having to change anything. And now it's just a matter of putting the covers back on, which just need to snap into place, and then I just have to reattach the screw from the back. But there they are. So buttons work. The connection to Home Assistant works. Not much else I can think of doing at the moment. And one more quick little thing here before I end this video. While I was working on these plugs here for like the past several days, I actually received these in the mail. I had ordered them like over a week ago. And they are CH340 chips, USB to like the UART. And each one of these is a set that comes with like one of these ESP-01 little boards. And so I decided to test one out, and I could not for the life of me figure out why it wasn't working. The little COM port was showing up, but it could not get it to do anything with one of these little ESP modules. And as I said, they come as a set, so you'd expect it to just work right out of the box. Well, I started doing a little bit of investigation, and it turns out that they didn't connect the enable line to 3.3 volts, which the enable line obviously enables the chip to function. So I had to put a little jumper in between the 3.3 volt line and the enable line of one of these little adapters in order to get this to work. And then I was finally able to write to it and or not write to it, but like access it and be able to like read some information off of it. I don't have any of these like programmed for anything just yet. I did have some previously that I had ordered elsewhere, and so these work, and I had used it with my other little USB transceiver, so I knew that they worked. I just couldn't figure out why they were not working with this board, and that's why, because there's no enable going to 3.3. So if you happen to be looking into some of these, or you have some of these and can't figure out why they don't work, well, that's why they don't work. All right, so that's going to do it for this one. I hope that was at least kind of interesting, and thank you all for watching. I will see you guys around the bench.